Hello, everybody. Okay, welcome. Today we're going to talk about human population and population growth. I have two lectures for today. The first one, so it's human population part one and then human population part two. I recommend that you read all of the articles for today before watching these lectures. I think it'll just help you sort of understand the lectures better, and then you can go back to the articles to kind of go over any details you didn't understand after the lecture, okay? All right, so human population. So we start with this topic because it's a huge, we ended in the last class talking about the Anthropocene, right? And how the environment has changed in part because humans have making such a big impact on the planet. And one of the biggest reasons for this is the dramatic growth that we have had in human population really over the last century. So I start with this, and so the slides that are posted on Moodle, you can, the slides actually have this figure embedded so that you can click on it and it will take you to the Smithsonian website. And I like to show this because I find that students often don't have a very clear idea of how long humans have been on the planet. So this is the timeline of human evolution and related species. So just as a reminder, we are classified as the genus Homo and the species Sapiens. So we're Homo sapiens is our genus and our species, and we're actually considered a subspecies of Homo sapiens, so we are Homo sapiens sapiens, which translates to all knowing. So we have a very high opinion of ourselves. And so there are other humans that are in the species Homo, that are in the genus Homo, that are not the same species as Homo sapiens. Probably the best well-known of these are what are sometimes colloquially called the Neanderthals, which would be Homo neanderthalensis. And if you've been following the news the last, I guess, maybe 5 to 10 years, increasingly it's been shown that modern humans do have some Homo neanderthalensis genes, believing that perhaps Homo sapiens and the Neanderthals were interbreeding at some point. But there's these other, sometimes less known humans. There's Homo erectus, which you can see is the earliest or the longest living of our genus, and also sort of one of the earliest to evolve. And a very little known one, and actually recently discovered, called Homo florensis. And this was a smaller sized human that was believed, was found on the island of Flores, and fairly recently. And if you go way back, so let's go back, a couple million, 3 to 4 million years ago, you have our ancestors, Australopithecus, right? So these are the genus Australopithecus. And then even before that, we get Ardipithecus. So these are considered kind of related ancestral species that are related to modern humans, right? So when I ask students often, how long do you think that humans have been on the planet? Typically, humans throw out numbers like 2, 3, 4 million years. But if you look at this, modern humans, we've only been on the planet for a few 100,000 years, right? So here's your million-year mark. These other species of not humans, but these related species that sometimes you've seen fossilized records of are actually the ancestral related species that were on the planet that many million years ago. But modern humans are actually very recently on the planet. And all these other humanoid related species have gone extinct. So Homo sapiens is the only genus human species that is living on the planet today, which I hope all of you would have known. Okay, so when I talk about the Holocene, right, this 10,000 period, this little blip at the end of Homo sapiens here, that is the period when modern Homo sapiens have really developed all of our, what we kind of know as civilization, right? Our ability to, um, uh, use agriculture, modern uses of growing food, right? So all of that is a fairly recent phenomenon. Okay, so I hope this, part of the reason I start with this is because I think it helps us understand a little bit about the fragility of our species on this planet, right? That we haven't been here for very long, and we've been here during this sort of, we've been here for a very fluctuating climate, but the vast majority of our sort of success has been during this Holocene period. Okay, so these graphs were in the article on the Anthropocene, and this is, these are all referring to what was discussed as the second stage of the Anthropocene, otherwise known as the Great Acceleration. The Great Acceleration is the period from 1950s to the present, when we see this exponential growth curve. I'll pull out my laser pointer here, I like this little guy. So when you see the exponential growth curve, right? So right around here is our 1950s mark. You can see they've highlighted it in red. And suddenly world population goes from this slight increase to an exponential growth. Other things we see is real gross domestic product, direct foreign investment, primary energy use, urban population. They're all following the same exponential growth trend. And what we see in conjunction with this are other social indicators: water use, paper production. In the article I had at McDonald's, which I always think is funny. And then over here in our Earth system trends, we can see the same pattern: carbon dioxide, nitrous oxide, methane, right? So you can see when you chart all of these, a very clear connection between human presence on the planet and these variables, these Earth system indicators that we're using to understand our planetary boundaries and human impacts on the Earth, right? So all of this is part of this period called the Great Acceleration. And hopefully you did the readings, the Stefan et al. 2007 article that talked about what the future holds, right? Future pathways. And they gave a couple different future scenarios. One of them was collapse, which is what those of us in the environmental science realm are hoping to avoid through these sort of dire warnings about us needing to change our human-environment relationship. But other potential scenarios are humans becoming better stewards of the Earth, learning to live in ways that decrease our impact, and potentially using technology to avoid some environmental collapse. Okay, so here we're seeing the world population in this exponential growth curve, and this is really what we're going to zoom on today. What has happened with the world population? Why has it grown so quickly? And what are some of the impacts for the planet? Okay, so I mentioned agriculture, right? Last 10,000 years. So we're seeing right around here, about 10,000 years ago, we have some of the earlier cases of agriculture. And again, note here that this is a little bit ironic because it's showing human population, but of course not, this would not be Homo sapiens, right? Okay, so we have this slow increase in human population, right? But it's mostly stable, right? Slight increases, but mostly stable. And then it starts to grow. We're seeing this increase around the middle of the last millennia. And then around the start of the Industrial Revolution, we start to see this greater increase in human population. And then with the Great Acceleration is this massive taking off into the present, where we're at about 7.5, slightly more billion people on the planet. Okay. So some things that for you to think through on your own, maybe discuss with your class partner at some point. So what are the factors that have controlled human population historically, and how have those changed in the last century? So if you want to kind of think about that for a minute, you could pause the video, maybe jot down some of your own ideas. before I share some of the thoughts that I have on this, and that would have been in the readings. Okay, so in particular, we have had a decreased death rate due to improved medicine and sanitation, in particular the germ theory of disease. So right now we're, of course, experiencing this not understanding disease and not understanding where it's coming from and how it's transmitted and all of those things. Well, imagine just a couple hundred years ago when people didn't have any concept of how diseases came, right? So the germ theory of disease, where we could start to understand that bacteria and viruses were causing diseases, and if we had improved sanitation, we could improve our health. That's a very recent phenomenon. And so once we understood this, we're able to start to decrease the death rate. The other thing that we've seen is decreased infant and child mortality, which means more people are living to become adults. And then finally, improvements in agricultural technology to avoid famine and starvation, right? We still have huge issues of hunger on this planet, and we'll talk about that a little bit more next week. But we've improved, we've become so much more efficient in agriculture that we've allowed the population to really boom as much as it has. Okay, so this is another one of those interactive pages that if you click on it, it will take you to the World Population Clock, where you can actually watch this population change. So this is not updated for today. This is a couple months old, I believe. And so you can click on this and it will get you to, it will show you the world population changing in real time. And so, and you can actually go ahead and you can look at it by country, you can look at it by region of the globe, and it will just show you really that we're having this, even though we have, daily deaths, overall, we're having a general trend towards a growth in population. We're going to talk about why that is. This is one of the checkout things that I posted. This is a website, and what I like about this is that it shows you, it imagines that the earth only had 100 people on it, so it's looking at everything in terms of percentages, right? There would be 50 women and there would be 50 men. This would be the breakdown from according to continents, and I just think it's really interesting it helps you to sort of get this massive number of 7.5 billion people into something that's a little bit more tangible. Okay. So what are the things that contribute to our changing population size, right? If we're talking about a nation, right, the things that are going to increase population size are births and deaths, and immigration, people entering the nation, and emigration, people leaving the nation, right? If you're talking about the world population, that would just be your births and your deaths, okay? So if you want to calculate the global population growth rate, you would need the crude birth rate and the crude death rate divided by 10, right? And that was in the Friedland reading, which is just the population, the birth rate and the death rate per every 1,000 people. And then you divide it by 10, and that's going to get you a population growth rate. So here is a historical world population growth rate. You can see that this high point, right, at the sort of end of the baby boomer generation, we had about a 2.2% population growth rate. And then moving forward to around today, right, we're at about a 1.1% growth rate. So it's a much lower growth rate than we had only 50, 60 years ago. However, 1.1% is still growing, and we're going to talk about what that means on another slide in a second. Okay, and I already mentioned this, national population, the difference is births and immigration, death and, birth plus immigration minus death plus emigration divided by 10, that's going to give you your change in at the national level. Okay, so this is just showing you generally the predicted or projected population growth by country. And what you can see on this that I like to just show is what areas of the world are growing in population and what areas are actually contracting or staying roughly the same. So the only ones that would be contracting are in this very light color, right? And then all of these other regions are growing, albeit some of them quite slowly, right? So this light gray is growing more slowly. And then as you move into this color, I don't know what color that is, brown, it's growing a little bit more quickly. And then you're seeing this that's predicted to double in population between 2005 and 2050 would be these regions of the globe here. And this is related to the idea of a fertility rate. So fertility in demography does not actually mean how easy it is to get pregnant, which is one of the, which is the way we use that term colloquially. Fertility rate actually means the number of births per woman, okay? So the average number of children per woman is your total fertility rate. That is not the same thing as fecundity, which is that ability to conceive. Okay, so the total fertility rate, what we're seeing here is that this would be related to your idea of whether or not a nation is growing. So in the United States, we're around, I think we're around about 2.1% right now. So that, I'm sorry, not 2.1, 2.1 children per woman. And the replacement rate, oh no, I'm sorry. Okay, where I believe we're at about 2.3 in the United States right now, and the replacement rate is 2.1. Now, you can't have 0.1 children, but again, this is the average across the population. And so if it is slightly higher than 2, that is a replacement rate in the United States because we have a relatively low death rate among infants and children, right? If you had a higher death rate, then that replacement rate would be higher. And if you are below 2, then you are below the replacement rate, right? So these areas that had, most of the areas that had a projected decrease in population would have had a, either a low fertility rate or emigration, right? Or people moving out. Now, what you actually saw is some of these places actually are, even though they have a below replacement rate, they're still projected to increase, and that would likely be due to immigration, okay? So these are the factors that are impacting a overall population growth within nations and then across the planet. Okay, so the doubling time for the human population. Remember back when we talked about it when it was at 2.2%, right? So when the world's growth rate in 1963 was at 2.2%, the doubling time is just, this is just a quick sort of mathematical way to calculate it. You can take 70 divided by 2.2 and you will get the doubling time. And so that's approximately 32 years. And so in 32 years, the population, so between 1963 and 1990, the population would have potentially doubled on the earth, right? And that is something important to keep in mind because I find that often there's sort of a generation gap between my parents' generation is the baby boomer generation. And I think I've noticed in conversations with that generation that sometimes there's this idea that the human presence on the planet isn't that big, that there's so much open land out there. And I think a lot of that comes from the fact that the population was less than half what it is today when they were children. So if you think about, my parents were born in 1947, we were looking at, I'd have to relook up the number, but somewhere between around 3 billion people on the planet at that time, right? So less than half of where we're at today, maybe only 2.5 actually, but less than half of where we're at today. And again, we're looking into the future. We're coming up on 8 billion people on the planet. And we're projected to get up to 10 to 14, depending on some of the estimates that you that are in the reading for today, before this levels off. So human presence on the planet today looks very different than what it did 60, 70 years ago. Okay, and then if you look at this drop, right, to more recent times, about a 1.1%, the doubling time is 64 years. So that means that if nothing changes, right, in terms of a decrease in growth rate between now and then, we'd expect to have go from 7.5 billion people to 15 billion people on the planet by the time I'd be pretty darn old then. And so this is and of course, these exponential growth curves have been all over the news recently because it's a similar concept when you're talking about epidemiology, right? How that one person impacts, multiple people, and that's how something can spread really quickly. Well, it's the same thing with population. If my grandmother was one of 8 siblings, if she had eight children, and the next had eight children, it's very easy to see how quickly a population can grow. Okay, so this is this idea of carrying capacity that if you haven't read about yet, you will read about it. Which is that any ecosystem, and this is a concept borrowed from ecology, any ecosystem has a limit to how many numbers of a given population and species it can hold, right? It can allow to live. And this idea is pretty basic. It just has to do with the fact that there's only so much food that can be produced in a region. And so at some point, that population will run out of resources and it will die off of either starvation. Sometimes overcrowding would lead to sickness and disease. And so the article that you read talked about the potential carrying capacity of the planet, right? And it's believed that we've already adjusted our carrying capacity a couple times through innovations in agriculture and technology. We've allowed more people to live on the planet than could have lived historically. But eventually, just basic physics says that we would have to run out of resources. So the question is when. Some of the higher estimates would say, maybe we could support 14 to 15 billion people on the planet. Some of the lower estimates say, no, when we get to 10, we're going to be in trouble. And so this is what we're trying to understand. And this is one of the things that we're faced with when we're trying to think about how to be more stable in the Anthropocene. Okay, so here in Greenville County, we are a fast growing county. Last time I checked, the Greenville County growth rate was 1.7%, which means that we would be doubling in 41 years. Okay, so when you think about that from a planning perspective, in 41 years, or by 2060, since I did this in 2019, by 2060, we would require twice as much water, twice as much food, living space, schools, road, etc. Okay. So 41 years might seem like a long time right now, but I'm from the Chicago area, and when I go home and see the area that I was growing up in some 30 years ago, it is amazing to see how much of that area that was once farmland, it has now become living space and schools and roads. And this is one of those things that contributes to the massive sprawl and growth in a population or in a region. And it can become a huge challenge for planning in a city. In fact, Greenville right now is looking at, they're trying to come up with a city plan going into the future. I forget the name of it right now. Okay, and then finally, the last piece I want you to understand about these trends is that more people are moving into urban areas. So we have seen, particularly in this country, it's been very strong since about the 1950s and 1960s. So right around here is when we started seeing massive immigration from farms or from rural areas into cities. Right? And the same trend we're starting to see more recently in some other countries. And so overall, we're ending up with a net, most of the world's population is living in cities. And more, the food for those cities is being produced through mechanized agriculture, which we're going to talk about some of the implications for that next week. Okay, so here's some basic, this really gets to the end of our point about population and general population trends and demographics today. In the human population, so take a break, stretch. In the human population 2 lecture, we're going to talk about some theories for what this means for impacts on the planet and sustainability.